Most drones don't fail because of bad flying. They fail because someone bolted the wrong payload on top of them. You can have a perfect airframe, solid motors, clean ESCs, and still end up with a system that can't complete the mission.
And this is because the payload is the mission. Everything else, the frame, propulsion, the power, that all exists to support what the payload needs to do.
Yeah, and most people treat it like an afterthought, and that's where they get it wrong.
Yeah.
I'm Joshua Hill, and this is the Swarm News, where veterans and engineers talk about defensive tech the way that it actually works. Real world sUAS systems with no fluff. And with me is my co host.
And I'm Vincent Lewis. And today we're breaking down payloads and what they are and how they impact the aircraft and how to choose the right one for your mission. But before we get into that, I'm going to go over a little bit of the news that's worth going over for the current events and things that's happening around the world and on the military and civilian side. A couple of those. One is military side, Quantum Frontline Industries. It's a German company that are combining with the Ukraine in a joint venture that will help them to complete a production of its first batch of Lenza tactical drones for delivery to the armed forces of the Ukraine. It's marking a shift from initial setup to a stable serial manufacturer, but the Build with Ukraine initiative in mind. The company now plans to scale up capacity and accelerate it to deliver all these drones through 2026 and focus on stable, predictable supply aligning with Ukraine's operational demands. Lenses drones developed by Frontline Robotics and already a battle-tested, very good system. They offer enhanced range, a great payload, they're more reliable, and encrypted comms for multi-rolled tasks, which is a massive thing. So they can do more than just one thing, which is very helpful, especially for a small drone. And this includes strike, reconnaissance, logistics support, and operations for missions in highly contested and jammed environments. On the civilian side, Extra Technologies has just validated their X8 version of a UAS that has the capability of flying 2.5 hours of flight endurance with 7K of payload capacity, which is pretty amazing for something that can fly that long with that much weight. And the biggest one is in a X8 configuration. The X8 configuration is well known for only producing enough thrust from the top rotors, and the bottoms are lacking in power, a third of the thrust that can be produced from the tops. So that would be a massive change in whatever they're doing to make that work for 2.5 hours is great. The other one is Mana Air Delivery, which is an Ireland-based company in Dublin, raised $50 million in a Series B investment fundraising to bring a total fund to around $110 million to scale its suburban drone delivery network. The company has already conducted over 250 commercial UAV flights and plans to launch up to 40 new sUAS or 40 new UAS bases in its builds for the next generation of autonomous logistics infrastructure. It's backed by ARK Invest, ISIF, Schooner Capital, Coca-Cola, HBC, and others. Mana now aims to aggressively expand its proven tech and unit economics across the US and Europe, which that's going to be a massive change for a lot of the drones coming into the realm, especially in the commercial areas. So that's going to be a big one going forward. That is pretty much the news for this week. You got anything, Josh?
No, nothing from me, man. So this is part 6 of our part 7-part build series. We've covered the brains, we've covered muscles, the power link, and now we're talking about what actually delivers value. Let's put it simply. What is the payload? Can you explain what that means?
Yeah. So payload is everything that the drone carries to accomplish its task. Either cameras, LiDAR, thermal sensors, RF sensors, the package itself, if it's carrying a package that is being delivered and is not required to fly on the system, is pretty much its payload.
Okay, so if I strip everything down, the drone simply exists just to move the payload around.
Correct, exactly. The aircraft is a support system for the payload that it's carrying. And it's the reason that it exists in a way.
Okay, so if I pick the wrong payload, everything else just breaks and starts breaking, there's issues?
No, not really, not immediately, but you'll see in the performance, degradation, short flight times, instability, overheating, and poor data quality if you add on the wrong payload to your aircraft and it's not built to be able to handle that payload that you attach to it. So it's only meant to be flying, then that'll be the best it'll do. If you try to add on, say, some RF sensors that are meant to see a specific signal on the ground or a camera, and you add in that to your power system, you're going to probably lose power and a lot of other things. So, yeah, that kind of gives a little bit more of a quality understanding of it.
Okay, so would you say if your payload is wrong, your system is lying to you?
Or underperforming is the best way to kind of put it
Okay.
until it matters.
Okay. So let's talk about the one thing everybody here actually cares about, the weight.
Yeah, that's a significant one. Weight is the first constraint. Every gram you add increases the thrust demand, which increases current draw, which reduces flight time, which is increasing thermal load, which is literally causing other problems that if you don't account for it, could cause you more of an issue than you really want.
Okay, so what you're trying to tell me here is that more payload equals less performance? Is that always the case?
Generally, yes, but it's not just weight, it's the power draw. If you think about it, if you put on say, a DSLR camera and that payload pulls power from your system, it could draw way more than what you're expecting to. And especially if you're not expecting, it's like adding a DSLR camera to a quadcopter. That quadcopter is not meant to carry that much weight. So even if it gets in the air, you're going from what you may have had in 5 to 6 minutes down to maybe a minute or two. And you may even break some stuff while you're doing it. So it reduces the endurance just as much as it adds mass.
Okay, so you're telling me that you're fighting two different things at once. I'm fighting the weight of the payload and the power that it takes to consume to do what it needs to do.
Exactly, and most people only account for one at times. You may not think about, "Oh, you know what? I can add this to it, and this will be the best way to make it work," and not realize that when you add on that, sometimes you may not even though it may not seem like it's that big of a significance, like you add on a GoPro to a, little FPV drone, that way it could be enough to where you can take off a minute of your flight time.
Okay. So as you just said, I mean, you're talking every gram you add is just an extra tax that your mission is taking on.
Correct, and most people don't know how much you can exactly add to it, and they don't understand that that extra weight being added to your system is really is significant enough to where sometimes it can take away, especially if it's running off the power of the system itself. If it's running off that one battery, you're taking direct juice that's made for it to fly and it's actually taxing and paying a price to the aircraft itself.
Okay. So break this down for us then. What are the main payload types and categories?
There's three big ones. There's probably some others, but these are just kind of your simple ones. In imaging, you have your RF, your thermal or multispectral or EO/IR type cameras, just regular day cam sensors that basically that's what most people are putting on a regular camera or some type to inspect, take video, take screenshots, take a screen capture, or just, basically taking pictures. Then you have other sensors that you can be put on it in combination or individually, which are the next one, which is the sensor. Kind of make sure it's the first one's images. The next category is sensing, which is like your LiDAR, RF, gas detection, those type of a sensor that they can see things that is outside of maybe the visual spectrum of things. Then you have action-based sensors or systems that you can put on there, which is basically delivering a package to a place. So it's like a release mechanism to let something go to the ground or spraying. So like in like case for agricultural methods where a farmer could put one of those over top of the field and spray their field with pesticides in order to kill bugs or to even get fertilizer or some type of manipulation system where that system is made to pick up, move different processes or something even like what we're seeing now where you have drones that go up and they have spray nozzles on them to put out a fire, wash windows, wash the building itself. So you have multiple different ones and basically action-based type of systems.
Okay. So which one of these do you think stresses the systems out the most?
That one's kind of a tough one. Depends on what you're doing, but LiDAR and active sensors tend to hit both power and weight hard because it's got to draw from the power from something. It needs to also have an ability to process that information and send it back to the flight or the flight controller or to the co-processors such as Raspberry Pi for it to actually recognize and understand what it's doing. And if it's on a gimbal or a camera, is need to be stabilized. If it's something that's mounted to aircraft, not as much. So that means it's less of a power draw. But delivery systems hit center of gravity and dynamics and load on it also. So you got a lot of different ones. So it just depends on what your sensor or your payload or whatever your payload is in general that's on
Okay.
the aircraft.
So it's not just what it weighs, it's also how it behaves.
Yes. Because if you
Okay.
think about it, kind of hit it on that aspect of it, exactly a aircraft that has, say, like what we were talking about back for a long time ago, like the DARPA challenge. You put 100 pounds of weight on there and it's swinging, those motors have to adjust and deal with that type of stress being put on it, not only from the power side, but from the frame itself. The frame has to be able to be in a place to where it can stabilize the aircraft, and also the props need to be able to maintain that weight because if you put the weight that thrust is being produced by the props themselves. So if they're flexing too much because the added weight on it, that's being picked up, it can snap them. You add in the power draw that's being coming from it, it can reduce the amount of draw and or reduce your flight time and draw to your systems, causing more heat, causing more problems that can compound over time. In ways, it destabilizes the aircraft in a way that a static load won't.
Okay. So let's talk about something people don't think about enough, like your center of gravity, because you were just talking about the swaying can adjust the payload's capability. So, like, let's get into that.
Yeah, so if your payload shifts your center of gravity too far from where it is, from when it needs to be able to stay stable, this is certainly for a fixed wing aircraft. You have to have your center balance on because if that center balance is shifted too far to the front, too far to the back, you won't even get in the air. For a multi-rotor aircraft, it affects it still, and you'll see more of a problem where if it's shifted too far front, the front load will have problems with getting up, and you'll notice it when you're trying to take off initially. If you punch it, maybe you can get it up and get it off, but it still will probably have issues where it's trying to maintain. If you put the load up front, it's like it's your physics. If it's too much thrust up here, you're not going to get enough lift in the front. The back's going to have it light. Airplane, if it's not centered in the aircraft right, if it's too far forward, your nose heavy. If it's too far back, your tail heavy. So if you're trying to take off, you're going to just crash. If it's
Mm,
too far forward, as soon as you try to take off, you won't get off. But if you do get it up, you're still hitting forward because it's too much weight. So center of gravity is definitely a must. So the flight controls expect a reference point, to be honest, when you're looking at it. And the force from your system is needing to be constantly compensated for that center of gravity.
okay. So you're basically flying a drone that's always correcting itself.
Yes, which it can automatically, especially in a Pixhawk, it's always trying to adjust itself in air. And that's one good thing about Pixhawks. They'll actually do a lot of your adjustments for you for hover, for different flight characteristics that's in there. So it can do its own adjustments and which it basically helps you to increase efficiency or inefficiencies in your aircraft and reduces the control authority so that it doesn't cause a problem. And it can, if you don't have that in there, it can cause you more of a problem that can induce oscillations that you don't want.
Okay. So if your center of gravity is off, your drone is flying itself the entire flight.
If it's off, you will have problems. Let's go like that. And you could be just riding along for it, but your aircraft won't always just work well. The flight controller is making up for what you didn't do, and if you don't do it properly, it's going to try its best to take whatever is being given to it and make it work. And sometimes the flight controller is along for a ride and not you.
Okay. So let's move on to something else that I think this is the area where a lot of people tend to mess up, and that's the integration of things.
Absolutely. The payload integration is your key part of what you want to do. Your payload needs to ensure its ability to be a seamless piece of your aircraft. If you're adding a camera, you need to make sure you know where you're going to put it and making sure that you have it mounted in a way where it can be attached to it properly. You need to make sure that it's capable of also getting the power and the wiring where it needs to be, and it's not in the way of other sensors or other components of the aircraft, like your landing gear. If you put it in a place where you're like, oh, I want it to be dead center, but your landing gear aren't in the right spot for it to be able to handle it because you didn't take that into account, you're causing yourself problems. So even if it's the basic landing gear too short for the payload to be on it, now you got to figure out a route around how you're going to get that in there on top of how you're going to land it. So the payload integration includes your power, it includes your mounting, it includes data interference or interfaces, and it also includes making sure that your software is compatible.
Okay. So what does that all mean?
You just can't bolt something on it basically and think it's going to work. You need to know how it's powered, how it's going to communicate with whatever your flight controller, other systems that are on it. And you can back up a little bit on the power part of it. You need to make sure that your aircraft can completely handle the power that you're adding with these payloads. So if the payload doesn't have enough of a power source, it's going to possibly stop working in the middle of it anyway. On top of it could draw too much and make you crash. And it communicates in a way, going to go into the next one, communication needs to be able to be in a place to where it's able to talk between the systems, and or if it needs to be able to function on the ground, you need to make sure that your systems are not causing interference between the aircraft and or what you're trying to work with on the ground. So you have like a DSLR camera that's on a gimbal that's needing to be adjusted and it's on a separate controller. You need to make sure that those signals are compatible with each other and that it can work the way you need to. The other one, it needs to not affect flight, which these all kind of common sense in a way, but if you don't know, this is what you need to really put into play. It affects your control of flight if that payload, like we were talking about a little bit before, if it is not centered properly and you start to moving, especially it's on a gimbal, that could throw off your center of balance, which is causing the aircraft to not fly right and or inefficiencies. On top of, like I was just saying, with communications and power, this all kind of works hand in hand. If those end up having problems because of that payload not being properly mounted, powered, and set up in a way where it can communicate with all the systems it needs to, this is where you're running into problems without properly designing it for it.
Okay. And when people say it should work,
Yeah, it should. Keyword should. And that's usually what and where things start to go wrong when you assume that it's going to do what you expect it to without properly designing it for that situation.
okay. So, and again, bad integration doesn't fail; it lies.
Correct. Its integration is not always perfect, but if you work to take into account what you're designing and our design intent is, it will ensure that your aircraft can work even when it isn't a perfect situation. But it can lie to you because you may not think of it all. So you need to ensure that it looks like it's going to work first before you do it. And you won't know it doesn't work when you know that it's going to be a problem.
Okay. So, give me a real world example where a payload actually killed the system.
Overweight. Overweight payloads will be the first thing. I've seen it before. Had an aircraft once where I designed it to be a 1 pound sensor put to the center of a airplane. And when we got out to do the mission, we were asked to put something else on, and I kind of knew it probably wouldn't work, but it was like, go ahead. And go figure, we shifted it forward just more outside the center of balance. And that extra half a pound of weight was enough for it to not even get off the ground. And it
Mm.
was it was an aircraft that we had to throw. So as soon as it got thrown, instead of it going up with throttle, it went up and right it to the ground on the nose. And anybody that knows RC planes that are made out of foam, you ain't gonna be able to do that too many times without messing up your aircraft. And that's where you run into problems. On top of, that's just a simple situation, but on top of, if you underestimate power draw and poor cooling, the system flies fine for a few minutes, and then all of a sudden you realize, oh, something's not right, because it'll let you know quickly that it's something not going to be ain't functioning well. Then you take thermal resonance into, or not resonance, you take the thermal draw or thermal sink into the process when you got motors that are heating up just significantly more over a flight from especially like a multi-rotor, you'll start to see those motors or your aircraft starting to sink. So throttle and voltage will start sagging, it'll take hits. And then now you've got a instability and the aircraft that's about to fail if it doesn't just automatically completely fail.
Okay. So, I mean, again, it's one of these things where everything looks good until it doesn't.
Exactly. Payload problems usually show up under stress and not on the bench. Trust me.
Okay. So if it only works in perfect conditions again, then it just doesn't work.
Yeah. And a lot of times it could be something as simple as a one setting. I had a test one time where one setting that you thought was supposed to be a yes because of it saying pass through complete or pass through for this way it was supposed to be in one of the settings, and it was set to yes, but in actuality it was supposed to be no. And it was to be able to release a system that it didn't work.
So how do we actually choose the right payload for us?
So start with the mission requirements and not the hardware. Ask what data do I need? What is the accuracy I need from that data or from the aircraft? And what environment am I going to be flying in? What is this going to actually have to function through?
Okay. So it sounds like we focus on the mission first, not the gear that we're trying to use.
Correct. Because if you try to just do one thing, if you design it for where you are, it'll probably work for where you are. But if you try to go somewhere else, as an example, I was flying an aircraft that was in Huntsville, that down there we're just almost at sea level. And that aircraft worked on the ground and got to where we needed to. But when I got to New Mexico to do some flights, the aircraft didn't make it up to the altitude. The problem being is density altitude. So something as simple as just it works well where you are, but it may not work everywhere. So knowing what you're expecting it to do, if it was at a place where I just needed to be in the air and get to a certain altitude, you're good. But if you're needing to get to a specific, you need to make sure that you take that into account always.
Okay. So what I'm hearing is here, build for your mission first. Don't worry about the tools that look cool. Look like focus on the mission.
Yeah. And that's how you get the systems to actually work.
Okay. So I mean, we've covered the brain, muscles, the power, the link, and now the mission.
Yep. In the next episode, we'll be talking about full system integration and how all this comes together. So taking everything you did, everything that we talked about, and going into a process that'll help you to figure out a good solution to building your system that'll function and not fail you.
Yeah. So drop a comment, tell us what payloads you're running, what you're trying to accomplish with it, and why you're running them. We'd love to hear from you.
Like, subscribe, and share this if you can. If you liked it, please also like and subscribe. And if you know anyone that would benefit from what we're talking about, please share it with them. And if you're just looking at this for the first time, thank you. Appreciate it. If you made it this far, hey, we greatly appreciate you getting this far for it. We've been growing for the last couple months, so thank you. And it actually means a lot to us. It's helping us to grow and help us to get through the algorithms. So,
Yep. We appreciate everybody. Thank you. I'm Joshua Hill.
and I'm Vincent Lewis, and this is the Swarm News.
Bye, y'all.
Later.